The following is the details and objectives of this course. Please read it carefully and start the course. The fuel system in a diesel engine sends fuel from the fuel tank to the combustion chamber and optimally controls the fuel pressure, injection volume, and injection timing according to the driving condition. In the past, the fuel injection pump that generates high-pressure fuel via its mechanical structure was used. But these days, CRDI that allows more precision control is used to increase engine performance and satisfy the emission regulations that are increasingly becoming stricter. The CRDI engine uses a fuel system that stores high-pressure fuel in common rail and then directly injects the fuel into the cylinder through the injectors. It is composed of a fuel pump, a fuel filter, pressure control valves, a fuel rail, injectors, and a pressure sensor. These components are optimally controlled by the ECU according to the driving condition and the driver's intention. Fuel flow in the low-pressure line is mainly divided into two types. The feeding type uses an electric low-pressure fuel pump in the fuel tank to deliver fuel to the high-pressure pump. Positive pressure is generated in the low-pressure fuel line. The suction type uses a mechanical low-pressure pump integrated with the high-pressure pump to suck in the fuel. Negative pressure is generated in the low-pressure fuel line. Note that the mechanical low-pressure pump has a priming pump installed on the fuel filter for air bleeding. In the high-pressure line, the pressure of the supplied fuel is increased to approximately 250 to 1,800 bar by the operation of the high-pressure pump. Then, the pressurized fuel passes through the common rail and gets injected into the combustion chamber by the injectors. At this point, the ECU controls the pressure control valves on the pump and the rail according to the vehicle conditions and driver's intention, ensuring optimum fuel injection. The injectors in common rail use a direct injection method that directly inject high-pressure fuel from the rail into the combustion chamber. There are solenoid-type injectors and piezo-type injectors. We will now learn about the operating principles of the solenoid injector. At the moment fuel is not injected, equally pressurized fuel is supplied to the control chamber and the needle chamber inside the injector. At this point, the spring keeps expanding and the nozzle is pushed downward. Then the fuel cannot be injected. When injecting, electricity is supplied to the solenoid and the ball valve is pushed up. This causes the fuel in the control chamber to back leak. At the same time, the high-pressure fuel in the needle chamber overrides the spring force and pushes up the nozzle, and the fuel can be injected. When the voltage waveform of the solenoid injector is analyzed, up to 5 injections are possible, and operation voltage is approximately 50 volts. When the current waveform is analyzed, the pull-in current in the main injection for activating the initial injector valve is approximately 20 amps. Then the hold current to maintain injector operation is approximately 12 amps. The two pre-injections are performed at 0.4 and 0.5 milliseconds, and the main injection that generates drive power is performed at 0.7 milliseconds. Following are the operating principles of the piezo injector. First, when the electricity is supplied to the injector, the piezo actuator increases in length and pushes the hydraulic coupler. The hydraulic coupler amplifies the motion of the piezo actuator and then pushes the hydraulic control valve again. At this point, the pressure rapidly decreases as the high-pressure fuel in the control volume is released, and this force lifts up the nozzle needle and injects the high-pressure fuel into the combustion chamber. When the piezo injector's waveform is analyzed, the operating voltage is approximately 110 volts. The current waveform shows that injection starts and ends when the piezo element expands and contracts, respectively. Operating current is approximately plus or minus 5 amps. This is the fuel flow in an engine with a piezo injector. The fuel passes through the low-pressure fuel pump, fuel filter, high-pressure pump, common rail, and is injected into the combustion chamber through the injector. Then the fuel returned from the high-pressure pump is sent back to the fuel tank. Up to here, the fuel flow is the same as an engine that uses solenoid-type injectors. But in case of an engine with a piezo injector, the fuel pumped from the low-pressure fuel pump is fed to the backflow part of the injector. In a solenoid injector fuel system, the fuel returns back to the fuel tank when backleak occurs in the injector. In a piezo injector, separate low pressure is supplied to maintain residual pressure in the hydraulic coupler inside the injector. The fuel pressure control valve regulates fuel pressure for the common rail engine to meet the target pressure as set by the ECU. In order to precisely inject fuel, the fuel that accumulates inside the common rail should be regulated constantly at all times. The fuel pressure control valve is what makes this pressure control possible. Let's check the actual vehicle data for normal open type. It shows an engine RPM of 4,500, target rail pressure of 1,600 bar, and actual rail pressure of 1,580 bar. You can see that the rail side control valve is closed to 47%, and the pump side control valve is opened to 13%, increasing the pressure. If the fuel system that supplies fuel is faulty, then the target rail pressure and actual rail pressure differ from each other. Therefore, comparison of the two is essential. Please review the lessons you've learned in this session through Simple Quiz. Let's wrap up what we've learned today.
Thank you.